Hello and welcome to my channel. So today let's look at the Leetcode 155. Today's daily challenge question. It means stack. So it asks you to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Um, so the example is push -2, push 0, push -3. Then get min, it should be getting -3. Then pop, the -3 will be removed. Then the top is 0, but the get min should be return -2. So let's look at this question is we can actually use the approach called two stack. So the first stack, stack 1 will store the numbers, all the numbers. Stack 2 store the means, the mean values. So we will always push to the stack 1. When there is a new number coming. But the stack 2 will we will only push if the number is smaller than or equal to, or we can call smaller than or equal to the stack top value. So if the number is larger than the top value, we don't need to do anything. So let's look at the example. So we can simulate the two stack using this using the given example. So the firstly push -2, right? So the min stack will always, because it's empty, so we need to push that value to the min stack too. So this one is called min, and this one is like a norm maybe. So then if we get the next number 0, so this norm will always push 0, but then we will compare 0 with -2. If 0 is larger than -2, so we don't need to push. Then we get the next one -3, because -3 is smaller than -2, so need to push again. Then we call the get min. So the get min is we just get the top value. We just return the top of the stack, min stack. Then pop. So we remove this -3. Then then we also need to check if the top value on the min stack is equal to the value we remove on the norm. If it's equal, then we also need to remove the top value. We also need to pop min stack. The next is top. So we just get 0. We just return 0, and the next is get min. So the get min is still -2, so we return -2. So let's implement this strategy. So we firstly define two stack. Can call stack 1 and stack 2. Or we can call min. Min, maybe min stack and stack. So Let's initialize both. Yeah, then next we need to implement push. So if the stack will always push the new value. For the min stack, if the stack is if min stack is empty, or min stack this value peak value is um is or we can call the given value is smaller than or equal to peak value, or we can call it the top value top. So then we need to also push this value to the min stack. So when doing the pop, firstly we get the value popped out of the stack, but we use that value and compare that value. If the value is the same as min stack's top value, then min stack also need to pop. So the top will just return the stack's top value, and the get min will return the min stack the top value. Let's check if so could work. Oh, there is no top. Then need to pick. Yeah, so I think maybe I confused with the C++ stack. So pick. Yeah, it's correct. So let's run this. Okay, great. Yeah, I just surpassed the 365 days. So so this approach, all the method will have O1 time complexity, push, pop, top, and get min. So this concludes today's session. So thank you for watching. See you tomorrow.